All right, today we're going to do some more factoring, but we're going to factor perfect square trinomials and the difference of two squares too. So a couple things were happening here. In this particular situation, you could do that. You can use this to, if you have an area of this square and you have an area of this square, and use factoring perfect square trinomials and the difference of that to find out how much taller is the left square. And we're going to practice that a little bit. Our essential understanding is this: you can factor some trinomials by kind of reversing the rules for multiplying special case binomials that you learn in 8.4. You're welcome to look back at that and see what that's about. Here's an example though. The rules for finding square binomials is such, so if you're squaring a plus b, that plays out as a plus b times a plus b. And if we FOIL that out, it's a squared plus double the product of a times b and b squared. It also plays out too for a minus b squared, and that is the difference of binomials. So a minus b times a minus b, and that plays out when we FOIL that as a squared minus double the product of a times b plus b squared. Any trinomial in the form of a squared plus 2ab plus b, or the other one, a squared minus 2ab plus b squared, this is a perfect square trinomial. So any trinomial in those forms is called a perfect square trinomial because it is the result of squaring a binomial. Reading the equations above from right to left gives you rules for factoring perfect square trinomials. So we're kind of looking for shortcuts, and as you recognize patterns, you'll be able to see them for this. So for instance, right here, key concepts, let's play this out a little bit. For every real number a and b, we can see that a squared plus double the product of a and b plus b squared, and we've seen this before, and that gets us to ab squared. So if we have this, we can get all the way to this. And the same for this one, a squared minus 2ab plus b squared, we can actually go right to this form of it, a minus b squaring it. It's like squaring the difference. If we look at it from an algebra perspective, like we just did, if we look at some examples here, if we know if we're starting with x squared plus 8x plus 16, we can go right to x plus 4 squared. And we'll talk about how you can do that even quicker. And if we have 4n squared minus 12n plus 9, we can start to identify, like, okay, I'm going to have subtraction and some squaring is going to happen here, and we can actually go right to this. And I'm going to show you about how to do that, how to determine what are actually your two terms when you're squaring something like this. And here's how you can do it. How to recognize a perfect square trinomial. Well, the first and the last terms are perfect squares. So the 4 and the 9 are perfect. The 1 and the 16 are perfect squares. So you know that we're looking at a perfect square trinomial. The second piece that we're seeing is that the middle term, so this guy right here, it is twice the product. Okay, so that is right here. That's what we're seeing it. That's the 2ab. It's twice the product of one factor from the first term and one factor from the last term. And remember, those factors are the same in the first one and second one. And let me show you here, okay? So let's try that out. Just on this example. So one factor from 4 is the 2. One factor from the 9 is 3. 2 times 3 is 6. Doubled, as we indicate up here, doubled gets you to the 12. Okay, so we can start to see how this plays out because we're looking at the negative one, and I can see right here that this is positive, so we know that this is a negative 2 times a negative 3. We can also try it on the top one here. This is a 1, so the term out here it's 1. This is 16, so the second term is 4. So 1 times 4 is 4, and we double it, and there's where we get our 8. So let's practice that out a little bit. Like in this example, factoring a perfect square trinomial, we can see that it's a perfect square trinomial by looking at the first and second term, and we can see that they're both perfect squares. we can play out here. So we can see that this is going to be 6, and there's a 1 right there. And so 1 times 6 is 6, times 2 is my 12. So that plays out here. I'm going to organize this a little bit differently here. I can see that my x squared is minus the 12x, and that is plus 6 squared. So I want to see the different terms here. And I can play that out even more, where it's going to be my x squared minus double my 2 terms, which is my 1x, and my second term, which is 6, and that's plus this 6 squared. And that brings us out to our binomial, which is x minus 6 squared. And we can see that all played out right here. Looking for my 2 terms, and then I'm squaring. And this negative tells me that it's going to be negative. Why don't you try it out? Kind of get the hang of this. Look at these guys, confirm that they are perfect square trinomials. Yeah, give it a try. See what happens. All right. Looking at my 2 pieces here, I got my 1 and my 3. So I knew they made up the parts inside. I know I'm doubling one of the x's, and I'm doubling a 3. So that gave me my middle term here. And cubing it. I am not cubing it. I am squaring it. Silly Mr. Weber. I look over here on this piece here, and I can see my 1 and my 7. It plays out here, 1x and the 7. And because of this subtraction here, I know it's going to be negative. Factoring to find length. Digital images are composed of thousands of tiny pixels rendered as squares, as shown below. Suppose the area of a pixel is 4x squared plus 20x plus 25. What is the length of one side of the pixel? Okay, what's nice about this is I'm noticing I got a perfect square, and I've got a perfect square here. So I can look and go, okay, well that 4 is made up of 2, and that 25 is made up of a 5. So I can work through that. I can see the first part, so I can see that it's going to be 2x squared plus double. I've got a 2x, and I've got a 5 plus 5 squared. So I can see all my pieces here. I got my 2x being squared and my 5 being squared, which is giving me my middle terms. All right, so now I can finish this. Ends up being 2x plus 5 squared. Oh, look at here. I got one for you to try. How exciting. Go ahead and press pause, and you try it out. You're building the square patio. The area of the length is this. And check out the 16 and the 81. See if we're working with a perfect square here. All right, when I play this out, I can see 4m minus 9 squared. But the question is, what is the length of one of the sides? One of the length of the sides is 4m minus 9. Let's keep going. Ooh, we're doing another recall from lesson 8.4 that a plus b times a minus b ends up being a squared minus b squared. So you can refer to a difference of 2 squares. Where you run into that situation, you can refer to it as a plus b times a minus b. So let's look at that for the factoring of the difference of 2 squares. So from algebraically, we saw that a squared minus b squared is equal to a plus b times a minus b. When we look at an example of that, we see a squared minus 64 is equal to x plus 8 times x minus 8. And we can start to see, okay, where that 64 is coming from the 2 8s. And the 8s are coming from the 64. And our minus is playing out in our second term here. And we can look at this one right here, this piece. We can see 25x squared minus 36. So we can see our 25x pushing out our 5s. We can see our 36 giving us our 6s. And we can see our negative here giving us one negative term. So let's try that out. Let's play this out on the pattern. So we have z squared minus 9. So I'm going to pay attention to that 9. I know that it's going to be like this. Rewrite the 9 as 2 squares. So we can see that it's z squared minus 3 squared. So I know I'm working with the 3's. And this shows me that my pattern is, there's my z's, and there's my 3's, and I have one of them be negative and one of them be positive. Check our answer in this case is when we FOIL this out, z times z is z squared, outside, inside, last. We simplify, those cancel out, and I'm left with z squared minus 9. All right, I want you to give it a try. Press pause, and you try factoring here. All right, v plus 10 times v minus 10, and s plus 4 times s minus 4. Those are s's. Okay, we're going to factor a difference of 2 squares, very similar to what we did, but notice we've got a different piece here. So we can look at the different squarings that happen here. So 16x squared can be written as 4x squared minus 9 squared. So that tells me right here that I can do 4x plus 9 times 4x minus 9. There we go. Why don't you give it a try? You try it on this one. Got it! All right, hopefully these are coming a little bit faster. I changed 25d squared to 5d squared minus 8 squared, and that gave me my 2 terms on this one when adding and subtracting because I'm looking for the difference. And the second part, no, I can't because it's not a difference of squares, so that would not work for this one. All right, for this guy here, we can, we're going to factor out a greatest common factor of a polynomial. Sometimes the expression that remains is a perfect square trinomial, or the difference of any 2 squares. You can then factor this expression further by using the rules from the lesson we were talking about. So let's look at this. Right here, look at this expression. So 24g squared minus 6, they can actually factor something out of there. Looks like we can factor out a 6. So if I pull a 6 out of there, I can see that it is 4g squared minus 1. You can factor that out. And then that shows me that I indeed have a perfect square in here. I can take 2g squared minus 1 squared. Okay, looks a little messy, but that allows me then to take this to 6 times, and here's my terms, okay, and I got to keep an eye on the negative here too. So 6 times 2g plus 1 times 2g minus 1. So what this let me do is by factoring it out, by pulling out the 6, I was able to use, again, my rules, factoring, looking for this piece right here, which plays out here, and just having the negative right here allowed me to see I needed 1 positive and 1 negative. Once you go ahead and give it a try, consider, go ahead and factor something else. You can see, are you looking at a perfect square? Press pause. All right, let's see how you did. First one wasn't too bad, just had to pull a 12 out of here. And then once I did that, I could see that I had a t square and a 4, which gave me t squared minus 2 squared. And that showed me what my 2 pieces are. All right, and because of the negative, one had to be positive, one had to be adding, and one had to be subtracting. When I look at the second one, I noticed I could pull a 3 out of all this, and I had a perfect square here and a perfect square at the end. And that allowed me to get my first part here, so 2x squared. And then I knew I had to use my formula again, so I'm doubling the first term, second term, and then I have my 1 square at the end, and that allowed me to get my terms here. And because it's adding all the way through, because it's addition of all of it, I was able to do 2x plus 1 and just square that term. And please remember to bring your 3 with it. Okay. That's that you factored out of the whole thing. All right, it's going to take some practice. You can do this. I'm proud of you. Let's make it happen. All right, speaking of making things happen, I'm going to teach a duck how to bark.